Good evening, everyone. My name is Rafael Gonzalez Lagos, and I am here to present the work performed by Dr. Sri Banerjee, Dr. Patrick Dunn, and myself from the College of Health Sciences and Public Policy at Walden University. The study on low socioeconomic status associated with higher cardiovascular mortality in the United States. All right. Cardiovascular diseases like heart failure, ischemic heart disease, and atrial fibrillation are among the leading causes of death in the United States. To this effect, socioeconomic status is a social index based on the income stratification determined by either an individual or a demographic group's wealth, occupation, and social class in a socioeconomic and ethnocultural setting. Moreover, we have the social determinants of health that affect both socioeconomic status and the social determinants themselves, disproportionately impacting lower income demographics and already lower socioeconomic status groups and related economic minorities. The low socioeconomic status and social determinants of health association could potentially yield a poverty and disease conundrum. Low socioeconomic status and related poverty-to-income ratio are known to lead or to exacerbate chronic diseases. However, there's not enough information about organ-specific mortality. In 2022, the CDC established that the social determinants of health framework allows for contextualizing the relationships from the individual through the societal levels. To this effect, where we use geospatial analysis with techniques for geographically weighted regressions and multi-scale geographically weighted regressions to evaluate spatiotemporally varying relationships such as the social determinants. This enables for a quantitative approach to evaluate this context. Therefore, we evaluated the relationships between low socioeconomic status and cardiovascular disease-related age-adjusted mortality. To this effect, we employ two methods: the Cox regression, okay, and using the nationally representative sample from Ann Haynes from years 2005 through 2010, where all participants were older than 20th and were followed up through 2019. Their socioeconomic status was determined using the total family income divided by the poverty threshold, which gave us a scale to measure or compare the ratio where it's smaller or equal to 1 versus when the ratio is higher than 1. The second approach that we use to evaluate this socioeconomic status and cardiovascular disease-related mortality was a geospatial analysis using geographically weighted and multi-scale geographically weighted regressions with data spatially joined from the 2018 Health County rankings and the Centers for Medicaid and Medicare. To this effect, we included the prevalence for cardiovascular diseases such as heart failure, ischemic heart disease, and atrial fibrillation. Low socioeconomic status was assessed using the percentage of population living under the 20th percentile of income, representing poverty, and high income inequality represented through income ratio, and that points to the contextual disparities and inequalities. Age-adjusted mortality accounts for the age controlling as a confounding factor. On the Cox regression analysis using NHANES, we found that the mean time of males, the mean time to death of male participants was lower or shorter than that of females. We compare 8.3 years for males compared to 8.8 years for females. The overall age-adjusted and gender-adjusted hazard ratios for high poverty-to-income ratio and low poverty-to-income ratios was 1.73, as we can see in the graph on the right, compared to the reference that we had. And then the adjusted hazard ratio remains strong at 1.98. As high as 3.33, both statistically significant, less than 1%. Okay, all of this was in the NHANES data and was after controlling for medical and demographic risk factors. The second approach included a geospatial analysis using data from the county health rankings and railroads and the Centers for Medicare and Medicaid for 2018, with information for 3,142 counties. We employed software from Arizona State University called MGWR 2.2 to perform the statistical analysis of geographically weighted and multi-scale geographically weighted regressions at a 95% confidence interval and a statistical significant threshold of 0.05. We also use ArcGIS Online and ArcGIS Pro 3.2 to evaluate the distribution of the geospatial relationships between social determinants, low income, low socioeconomic status, and age-adjusted mortality, as we'll see following. In this slide, we have results from the geographically weighted regression and the multi-scale geographically weighted regression, where we see in the bottom table the adjusted R-square for the linear regression was 0.646, almost 0.65. The same adjusted R-square for geographically weighted regression was larger, significantly larger, at 0.81, meaning that for the linear regression model, the variation of the outcome, which is age-adjusted mortality due to CVD-related diseases, was justified 65% of cases for the linear regression model, almost 81% of cases for the geographically weighted model, and approximately 83% for the multi-scale geographically weighted regression. We can see how in the upper right window, the multi-scale geographically weighted regression has a more compacted identification of these relationships, okay, pointing to a higher concentration of cases compared to the geographically weighted regression, where it's more dispersed. Okay, so the geographically weighted regression, or the multi-scale geographically weighted regression, provides a better or a higher statistical power for the evaluation of the association, statistically speaking. Here, using ArcGIS, we find that on the upper left window, we plotted the areas where people live with less than the 20th percentile of income. As you can see, it points to a higher concentration in the southern eastern part of the United States. The same was performed for income inequality, where the yellow area points to about the same southeastern area of the United States. Then we look at age-adjusted mortality on the bottom right map, where the teal color points to high adjusted mortality. All three conditions point to the same geographical spot, and that's where the map on the bottom left points to the concurrence or convergence of people living under the 20th percentile with high income inequality and related disparities. In this slide, we can see a similar analysis related to people living under the 20th percentile of income and affected by cardiovascular diseases. Let us focus on the upper right map, which points to the convergence of low of people living under the 20th percentile and high heart failure prevalence located in the same southeastern part of the United States. The bottom right map points to the same economic conditions suffering from a high prevalence of atrial fibrillation, same area of the United States, although a little bit more dispersed. And then we look at the bottom left map, okay, which corresponds to high ischemic heart disease prevalence, also for the same economic conditions, points to the same area in the United States. Therefore, we can infer, that people living under in the upper left map, we can see that people living under the 20th percentile with high income inequality concentrate high prevalences of cardiovascular diseases such as heart failure, atrial fibrillation, and ischemic heart disease. Here we did a similar analysis, but for income inequality, high income ratio or higher income inequality. In the upper right, you can see high income inequality converging with high prevalence of heart failure, same area of the United States. Then we look at the bottom right map. For the same economic conditions, high income inequality with high atrial fibrillation prevalence. Then on the bottom left map, we look at the same high income inequality conditions with high ischemic heart disease prevalence, all three pointing to the same areas. Thus, looking at the upper left map, we can infer that high income inequality relates to high age-adjusted mortality from cardiovascular diseases such as heart failure, atrial fibrillation, and ischemic heart disease. Concluding thoughts on the study, we see how low socioeconomic status impacts cardiovascular disease-related age-adjusted mortality, where males were observed to die faster than females or have a lower mean time to death follow-up than females. The overall age-adjusted, gender-adjusted hazard ratios for high to low poverty to income ratio was 1.73, almost twice, with a statistical significance of less than 1%. So significantly statistic. Cardiovascular disease patients living under low socioeconomic conditions have nearly then a twofold risk of cardiovascular disease related death than patients with higher socioeconomic status. This is shown by the adjusted hazard ratio, which remains strong at 1.98 among adults after controlling for medical and demographic risk factors. We can conclude that people in poverty disproportionately die from cardiovascular diseases in the United States. People in poverty disproportionately die from cardiovascular diseases in the United States. To this effect, cardiovascular disease prevalences such as heart failure, ischemic heart disease, and atrial fibrillation, in concurrence with low socioeconomic status, significantly impact age-adjusted mortality in the United States, specifically in the areas that were pointed, the southern eastern part of the United States, where it's greatest or most significant. The social determinants of framework, therefore, allows for the contextual evaluation of disease outcomes and predictor relationships from a geospatial and temporal perspective. Thus, that framework used in this evaluation and the statistical techniques help to elucidate the association between cardiovascular-related age-adjusted mortality and low socioeconomic status living conditions. People living under the 20th percentile of income are located also in areas of high income inequality. People living under the 20th percentile of income have a higher prevalence for cardiovascular diseases and like the ones we evaluated in the study, right? Heart failure, ischemic heart disease, and atrial fibrillation. Lastly, the multi-scale geographically weighted regression model renders a more accurate and local regression than the geographical weighted regression in accordance with the scientific literature. Because multi-scale geographically weighted regression is a refinement of the original geographically weighted regression model, which allows for spatially overlapping varying relationships varying at non-constant rates, as it is assumed by the original geographical weighted regression model. The most significant benefit of the multi-scale refinement lies in the reduction of statistical standard error and increasing statistical power. Okay. On the limitations of the study, further investigation is required to better understand and address contextual factors that force or imposes these conditions of low socioeconomic status in these communities and related income disparities or income inequalities. Though they affect human development, related economic growth, governing health dynamics, and related outcomes. So we need to understand more of the how, since we already measure what's happening. On the clinical relevance, understanding the impact of low socioeconomic status at the population and individual levels will inform decision makers in at least two fronts that are interrelated. The first one is the integral implementation of public health strategies that promote sustainable human development with economic growth. And the second one, as important, it informs medical practitioners and patients of the contextually best and most viable approach to address their illnesses and related outcomes. Future applications of the geographically weighted regressions and refinement of multi-scale will provide a more accurate and statistically sound identification and distribution of disease and related social determinants of health. This effect is more evident and accurate in a local context, such as the county, the census tract, where we can get more and more refined measurements. Thus, their application will help elucidate the disease the relationship in hotspots of disease and social determinants of health inequalities, converging in a single area to adequately plan and allocate resources to address the need of those communities and their related healthcare providers. Thank you very much for the opportunity. Here are some references on the literature that was used throughout this study. Good night.